Okay, we've got a couple new ways to prove triangle similarity today. Last week we knew a shortcut, and that was angle, angle. If we have two triangles and we can see that there are two pairs of corresponding congruent angles, then the triangles are similar. We've got two more. One of them is the side, side, side similarity theorem, which says probably what you think it says. If you have all three sides, all three corresponding sides proportional, then you can say that the triangles are similar. So you'd have to show these proportions here, make sure that they were all the same. Another one is the side angle side similarity theorem, and these are, reminiscent of your triangle congruent shortcuts. So this one is probably, again, just what you think it is. Side angle side means that if you have one corresponding angle congruent, in this case it's x and m, and then you have the corresponding sides proportional. So like xz would be proportional to mp and xy would be proportional to mn. Now these two pairs of proportional sides must be right next to the included angle. So that's where the side angle side is important. You want to make sure that your two sides that are proportional here and here are on either side of the angle. Alright, so you've got three shortcuts: angle, angle, side, 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 and side angle side. We're going to practice a couple of these today. Alright, let's look at this one. We need to determine which two of the three given are similar, and then find the scale factor. So if I consider the first two, and we'll see if they are similar, I don't know anything about the angles, so I've got to check all the corresponding sides. And maybe you're asking yourself, well, how do I know what side corresponds with what side? What you want to do is you want to just look at the longest leg in each triangle and compare that with the shortest leg in each triangle and the middle leg in each triangle. So, for example, in this triangle, 6 is the shortest, and in the second one, 4.5 is the shortest. So if these two triangles are similar, then 6 compared, or with the ratio of 4.5, must be the same as the ratio. I'm going to compare the longer sides, which is 12 and 7.5. So that 6 over 4.5 must equal 12 over 7.5. And this must equal, then the middle length would be 8 over 6. If you calculated that, these are not congruent. Okay? So we know the first two are not the ones that are similar. I'm going to check the second two. So I'm going to check the shortest side here would be 4.5 and 3. So 4.5 divided by 3 must equal the middle side. Here would be 6 and 4, the ratio of 6 and 4. And that must equal the ratio of the longest side, 7.5 to 5. And that is true. They all have the same ratio, and that ratio turns out to be 3 to 2. Scale factor, or the similarity ratio, is 3 to 2. Alright, now let's make a statement of proportionality, just so that I know everyone knows what that means and you can do this. All that is just saying write all the ratios of the sides proportional to each other. So NM is proportional to RQ, and then MP is proportional to QS, and then PN is proportional to SR. This is the statement of proportionality. Okay. Next, I want to make the similarity statement. And you should be pretty good at these by now. You're just going to go around in your triangle. You're going to say triangle NMP must be similar to triangle, and make sure that you match up the right order with the corresponding sides. We're going to start with R, Q, and then S. Triangle R, Q, S. Okay, let's look at the next one. I want to know, are the triangles similar? If so, state the similarity and the postulate or the theorem that justifies your answer. So we are going to use what they're referring to as the angle, angle, side, 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 or side, angle, side. The first one here in part A, you know you have your one corresponding angle that's congruent. And you also can see that you have these markings here. So from this, you can know that this triangle, triangle PMS, we don't want to have that. Okay, no PMS. Let's do triangle SMP is similar with triangle NMR. Okay, and again, the order matters here. And this is because of the side angle side similarity postulate. All right, let's look at part B. Oh, you guys are probably really awkward now. Sorry. All right, what I have in part B is, again, the information I'm given is an angle, an included angle, and then the two sides that are adjacent to that angle. So I want to make sure that my corresponding sides are proportional. So what I'm going to do is I'm going to look at my shorter side, which is 6, and that has to be proportional to 8. And that ratio there has to be equal to the ratio of 8 to 10 and 2/3. And that is true if you calculated that. So we know that triangle, we'll start with C, go to A, and then B, is similar with triangle J, and then look what we did on the first one. We went across our shorter side, so we're going to do the same thing, JKL. Okay, a couple more. Draw the given triangles roughly to scale, then name a postulate or theorem that can be used to prove the triangles are similar. So I have triangle ABC, and DEF. And I have some information about all of these, and I'll put that in next. All right, so I know that angle A is 28. And I know that angle B is 62. I also know that angle D and this one is 28. And angle F is 90. Okay, so I want there to be two, if I'm only given stuff about the angles, I want to show that there are at least two pairs of corresponding angles congruent, because if that's true, then they're similar. So I'm going to focus on this as a 90-degree angle here. I want to know, hopefully this is also a 90-degree angle. And it is. If you subtract 180 minus 28 minus 62, you have your leftover angle being 90 degrees. So the triangles are similar with the angle-angle similarity postulate. All right, last one. We're going to write a short little proof here. It says two isosceles triangles are similar if the vertex angle of one of the triangles is congruent to the vertex angle of the other triangle. Write a paragraph proof of the statement and include a labeled figure. So I'm just going to sketch an isosceles triangle here, A, B, C. And this is going to be my vertex angle. So here's going to be my congruent legs. Okay, then one similar, maybe make a little bit bigger. I'm going to make this angle the same measure as this one. They're going to be marked the same. They're congruent. And these legs are also congruent because it's isosceles, but they're not the same length as my first one I drew. So we'll call this D, E, F. All right, so here's your paragraph proof. We know that AB is congruent to BC, and we know that DE E is congruent with EF. And that's just because we know that to be true in an isosceles in an isosceles triangle. Okay, we also know that angle B is congruent with angle E because it was given. They told us to do that. Now we want to say these two triangles are similar. And this side here, AD, is proportional to DE, and that ratio has to be the same as BC is to EF because of the way that they're marked. They're congruent. So that ratio is definitely going to be the same. So I can say that triangle ABC is similar to triangle DEF by side angle side similarity theorem. Okay, many of you wanted jokes and pictures in these videos, and I haven't had time to figure out pictures, but I have a joke, pretty good. So what do acorns say when they grow up? What they say is, "Gee, I'm a tree."